Welcome to the ACH Foam Technologies AIA Presentation on Structural Insulated Panels. ACH Foam Technologies is an EPS and SIP manufacturer with strategic locations located throughout the United States, as you refer to our screen. Today's presentation will be on structural insulated panels, and our continuing education provider number is K155. Today's presentation will qualify for one learning unit, and the program is registered with AIA CES for continuing professional education. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. Today's objectives are threefold. One, to understand the basics of EPS insulation and structural insulated panels. Second, to become familiar with SIP features, benefits, energy efficiency, and construction details. And also to learn about projects employing structural insulated panels. First, we're going to look at the EPS insulation that is the core for 99% of most structural insulated panels. So it is a very important and very integral component in the construction of structural insulated panels. As you look at the screen, you're seeing on the left unexpanded resin on the left side of the screen and expanded resin on the right side of the screen. Expanded polystyrene is a thermoplastic closed-cell lightweight rigid foam, and it is an oil petroleum derivative where the raw material is then expanded to about 40 to 50 times its size, and it'll be expanded to a bead that ranges from 0.5 to 1.3 millimeters in diameter. What you're seeing on screen is a cut of an individual polymer, an individual bead. As you look at this, you realize this is what gives EPS its strength and water resistance. As you look at the honeycomb core, this is integral in every individual polymer that is fused together. Let's review some of the EPS benefits. First of all, EPS is a very energy efficient material. It has a high R value with little to no thermal drift, which means that you're going to have a consistent material, consistent thermal performance from the day it's made to 40 to 50 years later. It's also very moisture resistant. As you notice from the last slide, we have the closed cell structure, which makes it resistant to any moisture penetration. It's also vapor permeable, which means that it transfers vapor through EPS and away from the building. It also resists temperature cycling, performs very well in freeze-thaw conditions, and it will go through a very simple wetting and drying process that will not affect the thermal performance of the material. Some other benefits: it's very durable, it's very versatile, it's easy to handle and install, limitless customization, whether it be for construction applications or industrial applications. We can make this material to exacting standards. Another feature or benefit would be insect resistance, and it's perfect for below-grade applications where material can be treated with, in most cases, borates to resist the infestation of termites. EPS is also very environmentally friendly. It contains no CFCs, HCFCs, or formaldehyde, and has never been used in the process of EPS over the last 50 years. EPS is also recyclable. Material can be recycled and introduced into new material and still maintain exacting physical properties and standards. Projects using EPS can also help earn LEED credits. EPS is environmentally friendly. It contains no CFCs, HCFCs, and HFCs, or other ozone-depleting compounds. It is inert, it's non-nutritive, and a highly stable material. It will not decompose or decay, and does not produce undesirable gases or leachates. It is recyclable, and it is LEED friendly, allowing you to gain LEED credits towards certification. Let's review the quality performance of EPS. It is a very important aspect of responsible EPS manufacturing. When material is received at the plant, it is recorded prior to processing. An in-plant quality control testing is performed so that material can be UL listed, UL certified, and FM listed. UL performs unannounced quarterly visits and audits the manufacturing process. They will then test samples that are produced from block molding procedures. At that time, it enables us to provide nationally recognized materials. So when you're specifying using EPS, material is measured, identified, and traceable for each individual project. Let's review the SIP components that are used in the manufacturing of structural insulated panels. First, we're using an oriented strand board, or otherwise known as OSB. This meets PS2-92 standards. We're also using expanded polystyrene EPS cores, which we've just recently reviewed. And we also use a structural grade laminating adhesive meeting ICC ES AC 05. This is the same structural adhesive that you have probably seen for engineered lumbers such as glulam. Let's take a closer look at some of the SIP components. SIP components use OSB skins that are structural engineered wood sheathings. They're made from fast-growing renewable trees such as pine, poplar, and aspen. And this is from a self-regenerating forest or a plantation-grown tree. No formaldehyde is used in the process of manufacturing OSB. The adhesives that are used are very low VOCs with a cross-linked adhesive technology which equates to a very long-term durability. Taking a closer look at the SIP manufacturing process, OSB skins are cut to width and length, and then the EPS cores are run through an adhesive application. Panels are stacked prior to going into a press, stacking the largest to the smallest. The panels are then placed in a panel press and placed in there for a period of time depending on temperature, humidity conditions, to an exact pressure set in the press for anywhere from 45 minutes to 60 minutes. Material is then placed into inventory and cured for a minimum of 24 hours. Material is also tested, doing a pull-apart test for each batch of panels that are produced in the manufacturing facility. This is then reviewed by a third-party quality assurance agency that comes into our facility and tests on a quarterly basis, reviewing all records and reviewing all tests. SIP panels are approved under code reports, such as the ICC evaluation service. SIPs are tested to very stringent standards for both fire and structural. Materials have been proven for use on 15-minute, 20-minute, 30-minute, and 1-hour fire configurations. SIPs can meet the requirements of the following codes: the International Building Code, otherwise known as the ICC, the International Residential Code, otherwise known as the IRC, Title 25 in California. It is also NTA certified, HUD approved, and has various state and local agency approvals. It is also approved in Japan under their MOC Building Code approval. Let's take a closer look at some of the structural insulated panel basics. What are SIPs used for? Well, they're the exterior insulation and envelope of a structure. It includes roofs, ceilings, structural walls, and floors. Drilling down to some of the SIP features, SIPs provide structural framing, a thermal envelope, a structural grade exterior sheathing, and it also reduces air infiltration. 2x construction is an older technology, and to be much more energy efficient, it requires further steps like a vapor air retarder, sealed penetrations, higher density insulations, straight framing, exterior sheathing. SIPs provides all of those things in a one-step application. Let's look at the SIPS benefits. SIPS offers a structural framing system, and it is a wood-based technology. It's one of the major reasons that SIPS has been accepted widely in the marketplace because of that wood-based technology. It is a system that is very friendly to the contractor community. Okay, let's look at the SIP benefits with structural framing. You have larger sections, which enables you to complete a job much faster. The structural strength of SIPs outperforms wood frame construction when you compare axial loads. SIPs provides axial strength, transverse strength, and also shear strength. Panel blanks can be either site fabricated or factory fabricated. Let's compare the SIP benefits versus stick frame construction. As you look at the processes on the left and the trades involved on the right, you'll see all the processes that are required with stick frame construction and the trades that are involved. Framing lumber requires a framer. Exterior sheathing requires a framer. Cavity insulation requires an insulation contractor. A vapor air retarder requires an insulation contractor or a caulking contractor. Sealed penetrations, various contractors are involved with that process. Exterior air barrier, sometimes a siding contractor, sometimes a framing contractor. Drywall install would require a drywall contractor. When you use SIPs, a lot of the processes and the trades involved are eliminated. SIPs has the framing, the exterior sheathing, the insulation, the vapor and air retarder, sealed penetrations, and an exterior air barrier. All that's required is the SIP installer. The only additional trade that will be required in this process will be the drywall contractor. How much do SIP's quality and performance cost? Materials you can expect to spend an additional 10 to 25%. Labor, the expectation is that you are going to reduce labor costs by 30 to 40%. And the life cycle costing advantages of SIPs will save you even more. As the building saves energy cost, it reduces total operating costs, giving long-term savings to the owner. Let's look at the thermal envelope of SIPs. It is energy efficient, reduced energy costs. It's used in LEED certified projects and also used in zero carbon footprint projects. SIP's rigid EPS insulation cores eliminate drafts, and when made with the PerformGuard EPS are termite resistant. SIPs lower energy costs due to their stable R value, and large sections of SIPs build faster than any other type of construction method. One of the primary benefits of structural insulated panels is the reduced air infiltration. You take control of the ventilation within your facility. There are no drafts, temperatures are stable, and there is interior comfort. This is due primarily to the solid core nature of structural insulated panels. Other benefits of SIP construction would be the reduced noise and the fact that it's environmentally friendly. An additional benefit is that it has limitless custom designs. As you look on screen at the two facilities, two institutional buildings, one a college and one a middle school, it enables architects to design with structural insulated panels for walls, floors, and roofs. Many years ago, Oak Ridge National Laboratories compared the performance of SIPs versus stick frame construction, and they did a whole wall R-value test. What you're looking at on screen is in red a 6.5-inch SIP panel and a 4.5-inch SIP panel. That was compared to two different stick frame walls. One was a 2x6 stick frame wall, 24 inches on center, and the other one was a 2x4 wall, 16 inches on center. ORNL conducted a test comparing an R-Control panel house to a stick frame panel house, and the R-Control SIP test room significantly outperformed a 2x6 stick-framed and fiberglass insulated room in testing under identical laboratory conditions at the Oak Ridge National Laboratories. Results from a carefully monitored and instrumented study in ORNL's climate simulation laboratory showed that SIP construction is more energy efficient and far more airtight than stick frame construction. As we make the comparison between SIP construction and stick construction, as you're looking at the left graph, that indicates the actual CFMs, or cubic feet per minute, of air infiltration. SIP construction had 9 cubic feet per minute in terms of its air infiltration versus stick construction that had 126 cubic feet per minute. On the right side, we're making a comparison with the whole room energy use. It took 755 watts to heat the SIP structure and 840 watts to heat the stick frame structure. Each room was then subjected to the air infiltration and heat loss testing. Results showed that the SIP test room was significantly more energy efficient than was the 2x-frame test room. Let's take a look at building with SIPs, some of the details and typical connections that you can experience in designing with structural insulated panels. SIPs comes in a variety of sizes, from 4 foot by 8 foot up to 8 foot by 24 feet long. Panels are very lightweight and very easy to handle, although sometimes oversized panels may require some mechanized equipment. Taking a closer look at the basic tools required to work with SIPs, with the exception of deep cutting saws for single pass cutting of SIPs, the tools employed to install SIPs are common to other wood type technologies. Circular saws are used and modified chainsaws with guide. There are various components used in the construction of structural insulated panels. Panels are fastened with nails, staples, and screw fasteners. Adhesives are also used for all the wood-to-wood connections. Joints are then sealed with sealants and sealing tapes. When building with structural insulated panels, it is very important to follow the detail book provided by the manufacturer. There are many important details that are listed in there that need to be followed very carefully. One, in particular, is when constructing with SIP walls that you don't overcut the OSB facings at the openings. There are many very important details that are required when building with SIPs. Let's take a look at some of the connections that are used in connecting panels together for floors, walls, and roofs. The first one would be a spline, either a surface spline or an insulated spline, or sometimes known as a block spline. These are used to connect panels together and eliminate any thermal breaks. They're factory cut and they're sized to match the pre-cut spline pockets. Plates are also used to block panel edges. Let's take a closer look at the SIP connections using a block spline. As you can see from this detail, which is available in many construction detail books, that it is required to provide an adhesive sealant on all of the wood-to-wood connections, all of the EPS to EPS connections, and all of the EPS to wood connections. The next detail shows a surface spline. A surface spline is a 4-inch wide strip of oriented strand board that marries the panels together. The next detail shows a structural I-beam connection, which consists of an insulated I-beam that would marry the panels together, commonly used for roofing applications. This detail is a 2x-spline connection, which has 2 pieces of dimensional lumber that are fastened together and used for connecting more commonly floor panels and roof panels where you require longer spans and heavier load. SIPs have the ability to span long distances and create a structural roof, ceiling, and insulation all in one step. As you can see from this photograph, SIPs are commonly used for roofing and can be set into place with mechanical equipment in very large sections. Large panels provide the ability to easily span over trusses while maintaining structural support. As you can see from this photograph, SIPs are commonly used for roofing applications. Pre-cut ridge cap can be used to finish off the roof, or panels and plates can also be mitered to cut and form the roof edge. As you can see from this detail, this shows the roof ridge square cut using a preformed EPS ridge cap. There are many different foundation types that can be used when building with structural insulated panels. You can use a slab-on-grade, poured concrete, concrete block, precast concrete, or insulated treated wood. The two slides that you are looking at on the screen show on the left the correct application of a structural insulated panel over a concrete foundation. The one on the right shows the improper application of a structural insulated panel on a foundation. It is very important to make sure that the structural insulated panel does not come in direct contact with a concrete foundation. Some separation will be required, such as a sill sealer or a treated plate. One of the common questions that comes up when you're designing with structural insulated panels is, how do I provide for electrical in structural insulated panels for wall and roof applications? Well, as you can see on screen, an internal chase is cut into the structural insulated panel. This runs vertically and horizontally. As you're looking at this diagram on screen, you could see how standard electrical chases are cut into the cores of structural insulated panels. The common application is to run one vertically 4 feet on center, two horizontally 16 inches and 44 inches from the finished floor line to accommodate all of your outlets and switches. Now we come to the section in our presentation where we're going to take a closer look at some of the structural insulated panel projects. So let's move forward. Some of you may be familiar with this project. This is the Aldo Leopold Legacy Center. This was the first project that was built to a LEED Platinum level. The Leopold Legacy Center not only earned LEED credits, but earned the highest rating to date with 61 points. The building is predicted to have a zero carbon footprint. The next project is the Iowa Central Community College. This project was built to a LEED Gold certification. The Bioscience Building is the first community college project to achieve LEED Gold certification in Iowa. The next project is the Ruffner Nature Preserve. This was built to LEED Silver certification. The Nature Preserve is one of the nation's largest conservation areas that houses animal exhibits, a store, meeting facilities, and administrative staff offices. The Nature Center was designed to earn LEED Silver designation by incorporating elements such as a green roof, daylighting, geothermal heating and cooling, and a rainwater recycling system. Some other notable projects that have used structural insulated panels was the Robert Redford Conference Center. This was 16,000 square feet of roof surface using structural insulated panels. Another notable project was the Crex TV studio in Grand Junction, Colorado. SIPs were used primarily to reduce noise from an adjoining helicopter pad. The Severance Middle School used structural insulated panels. In the spring of 2009, architects specified structural insulated panels to frame the unique architectural features on the roof section of Severance Middle School. We chose SIPs for the rotunda roof and two-story gable roofs at Severance Middle School because of some special design challenges, explained Rebecca Spears of RB&B Architects. First, there were large vaulted areas, and we wanted to cut down the number of bar joist supports where there is exposed structure. The SIPs provided the long spans we needed to do this. SIPs also offered ample nailing surface for the installation of beetle kill pine decking used for the ceiling in each of these areas. The 8 1/4 and 12 1/4 panels were quickly and easily secured in place, providing a continuous wood surface without thermal breaks. Crew members at Precision Panels installed over 1,500 square feet of panels in approximately 45 minutes. Another interesting project was the Keystone Tennis Townhomes. 52,000 square feet of structural insulated roof panels were used to re-roof the 14 tennis townhomes in Keystone, Colorado. The next slide shows a typical application using structural insulated panels for walls and roofs on a very common residential application. Let's go back and review some of the SIP benefits. As we've discussed, there is tremendous design flexibility using structural insulated panels. Material can be constructed quickly and operational costs are reduced. Field experience indicates that building with SIPs is approximately 30 to 40% faster than building with traditional stick frame construction. SIPs can be designed and fabricated to work in all types of architectural designs. Building with SIPs is environmentally friendly. There are lower energy costs, reduced pollutants. The EPS material is used with a recyclable core, and the wood used in the construction of structural insulated panels has a regenerable wood species. No CFCs, no HCFCs, or HFCs are used in the manufacture of structural insulated panels. Let's look at some of the comfort features of building with structural insulated panels. It eliminates the air movement within the core of the panel. Noise infiltration is greatly reduced. There is no thermal drift. And material can be produced with termite-resistant EPS. Additionally, SIPs can be used for various levels of LEED certification and to meet a number of green building initiatives. Various support material is available for the design and specification of structural insulated panels. A construction detail book is available, complete specifications, load design charts for your engineer's use, and a construction techniques video. Let's take a look at some of the other EPS applications that can be used. One very common application for EPS is as a commercial roof insulation. Another very typical application, because of its strength and lightweightness, is for geotechnical applications, for highway construction, for green roof construction, and also for stadium seating. This slide shows EPS being used to create the risers for a stadium seating application. Other EPS applications include insulated concrete forms for below and above grade applications, or EPS can be used as an exterior sheathing over hard surfaces and also open frame construction. EPS is also commonly used for below grade applications, for below grade and under slab, and also as a waterproofing protection board. EPS is also used for a radiant floor panel. Hydronic radiant floor heating systems in basements, garages, main floor slabs, or driveway applications where concrete or gypcrete is installed and poured over the EPS insulation. Considering its versatility, EPS is used for architectural shapes, for stucco and EIFS use. This comes to the end of our AIA continuing education program. There will be 10 questions provided to you, and once you submit those questions, if you achieve an 80% score, you will receive one learning unit for this presentation.